Okay, in this case, I'm going to show you how to use OpenSpec. OpenSpec is basically is a spec-driven development, and this, let's say, framework was created because nowadays we are using a lot of vibe coding, and by now that is not that good for developing a really good project. It has many weaknesses. For example, you can all the prompts that you share with this AI, with your AI assistant tool, well, basically they are lost once you enter to this AI. Basically you don't remember after that, so that is a problem. With spec-driven development, the main idea is before even just writing a single line of code, we specify explicitly what we wanted to do first. So with this in mind, this framework was created. Although this is not a new idea, it was an old idea. There are several frameworks that are based on the same idea of spec-driven development. In this case, OpenSpec is just one solution. There are another solutions, for example, Hero from AWS, SpecKit from GitHub. So in this case, why are we going to use OpenSpec over SpecKit or Hero? Well, first of all, Hero with AWS, as far as I understand, it works with Cloud Code and is restricted to the AWS provider, let's say, something like that. Is a AWS tool. So, and as I said, it is restricted to Cloud Code. So that could cause some problems. The other alternative is SpecKit from GitHub. It is a good alternative. It is a robust alternative. It is taught for great projects, big projects, for larger teams, and it has a very sound approach, and it could be a little bit complicated at first, but it is a good one. But it is, as I said, it is especially designed for big projects, working with several developers. But in this case, if you are working as a solo developer and your project is a little project, proof of concept, an MVP, probably this is a good solution or a good approach to try, because as it mentions here, is a lightweight framework for spec-driven development. So here in this little tutorial, and this small tutorial, I will show you what is the basic idea of how to use this OpenSpec. Basically, because at the beginning it could look kind of confusing, because this OpenSpec framework has passed through several changes, so sometimes it can create some confusion on the user. So let's start here. Okay. Oh, this is what I told you about SpecKit, about Hero. So first of all, you must install it onto your at global level. You have here the command. I already installed it. So in here I will create a new folder. I will call it OpenSpec, and inside that folder we will work in our first small sample. So Once you install this at global system with this command npm, the next step that you must follow is to enter to that project and make an init OpenSpec cd OpenSpec. So now one thing that you must be take into consideration is that when you install this global package, in this case npm install Fusion AI OpenSpec, you will have some commands in your terminal that you can use, like this OpenSpec init. There are another, and like that, similar to this command, there are another ones, and beside that, there are another. When you init OpenSpec in your project, it will also create some commands that only your agent tool, in this case I'm using OpenCode, will understand. So for that reason, that can create some confusion. For example, when you use OPSX propose, OPSX apply, that are commands, but those are commands that are taught for your AI agent tool, not for your command line. So that should be clear. So let's do that. Let's run OpenSpec init. And here it will ask you what you want to do to start your project. It will ask you what is your tool. In this case I'm using OpenCode, but before that that is what I was telling you. It will create these skills. Basically, when you're using in this case I'm using OpenCode, it will create this, let's say, command OPSX new, continue, apply, but this should be understood as skills that you are calling. So we are going to see that in a moment. Let's put enter, and here you can select what is your AI agent tool. In this case I'm using OpenCode. I select it, and that's it. So as you can see here, I have in my folder, it is created a folder called specs, a folder called change, a folder called archive inside this changes folder, and a config.yaml file. So as I told you, I think I will increase here the font size. Give me a second. Okay, that's better. So as I told you, here we have our folder OpenSpec. It creates another folder called OpenSpec with changes, a spec folder, and a config.yaml. And inside this, let's say, hidden folder, you have here the skills that are created. For example, this one, propose, skill.md. It will give you all the details of these skills that your AI agent should read and then apply. And here are the commands to call these skills: OPSX apply, OPSX archive, OPSX explore, OPSX propose, and OPSX sync. So that's it. So okay, that is important because, as I told you, you shouldn't confuse this CLI tool, OpenSpec, with the skills that you are calling inside your agent AI agent tool. So in my case, I will start OpenCode. And the main idea of this project is the following. Well, before that, here we have a config.yaml file. Here the main idea is to give an overview of what your project is about, as is described in this example. What is the context? For example, what is your tech stack? In your case here it says TypeScript, React, Node.js. What is the domain, an e-commerce platform. So it is not mandatory to use it. It's an optional file. It should be better if you complete it. In our case, we will just leave it as it is originally. Then we are going to have this folder called changes. In this changes folder, will be stored the changes that we are currently working. Let's say that we want to add a functionality, and let's say we develop this functionality, everything is working fine, and then when we are happy with this functionality, we decided to archive it because we already finished it. So when this change is not more active and it was archived, it will be stored in this folder archive, and in the specs folder it will be located all these changes, but as a general view, as a source of truth, as mentioned in the tutorial here, or in this in the documentation. Maybe it's in the first steps. Okay, it is in getting started, I guess. Yeah, here. That is the structure that OpenSpec creates, the changes that are the proposed updates, the delta specs, the config.yaml, that is the project configuration, and the specs, that is considered the source of truth of that describes your system's behavior. So all of what I'm telling you now, it will be better understood when we work with a simple example. So the flow that this framework proposes is that first of all we make a proposal, that is what is the idea that or feature that we want to implement. After that, okay, this is okay, here, sorry, this is the main workflow that we will use. So we first propose the idea, what is the feature that we want to work. After we verified all the steps that is created by OpenCode in my case, if we are happy with that, we can then apply what was planned. Then we will synchronize our changes and then archive it. That is the main, that is the basic workflow that we are going to work. So let's go. So as it says here, we will start with this command opsx propose. So let's see, opsx propose, and here we have to propose a new change. So in my case, just to make this example quite simple, we are going to create a CLI tool that's just return our name after we enter it. So let's say create a CLI tool to greet a user. This user should enter his name, and you must return hello and their name. You should use you must use Python. So that is quite simple. That is all that it must do. So what OpenSpec will do is the following. You can directly pass as argument what is your intention, what you want to build, or you can directly pass the name, for example, greet user, and he will try to understand what is your intention. But just from my statement, OpenSpec can define what is the name of my change. So let's go, put enter, and as you can see here in changes, it will start to create what are the changes. So here it already decides a name. It's called Python greeting CLI, and as you can see here, it will create the proposal artifact, it will create the design artifact, the specs artifact, and the create task artifact. So if we go here, here they explain what are the artifacts. So basically this when you run this command opsx propose, it will create four artifacts. The proposal.md, that is the why and what of your project. So basically you are describing here what is the idea of your project, what you want to implement, not in detail, but why do you want to do it, and what is the tool that you want to build. And then in the design part is the how. That means what are your technical decisions. For example, it could be, if we are working with Python, probably you can decide, it could be decided here, okay, I want to use a certain Python version, or I want you to use some methods like input and print to show that. So it is decided in detail what are the decisions. And also it will create a task.md that it basically will describe the steps that the AI should follow in order to create the feature, and it will use checkboxes because these checkboxes will start blank, and when you apply the changes, it will check these empty boxes, so that way you know that it was complete. It is complete. So then in this specs folder, it will store the delta specs. So that way you will know if the requirements that you are working on were added, that means that they are new ones, if they are modified, or if they are removed. This is an important part because it will determine if it's a new requirement is added, it is modified, or it is removed. So that is. So let's see what happened here. So as I told you, the change that we are working on now is called Python-greeting and CLI. It creates the 4 artifacts, in this case the proposal, the design, the tasks, the specs folder. So let's start by the proposal. So as I told you, it was the why are you doing this, what are the changes, what are the capabilities, and what is the impact. I mean, if you want, you can change that, but that is the, let's say, the format that it uses. So basically it says you have here a new Python CLI script. that prompts the username, returns the greeting message formatted, and it handles the user input. Okay, that is the proposal. What is the design? Well, the design, it is the technical part, it is supposed. So what are the goals here? Accept username via interactive prompt, return the formatted name message, use only Python standard library. Okay, that's interesting. What you don't want? No command line argument parsing. Okay, that's fine. No configuration files, no external dependencies, no complex requirements. Perfect. So and here it has some methods, prints, and all that stuff. Okay, that's perfect. And then we have here the task. So first is to create a grid.py script file, and then add prompt for username input, add greeting, and as you can see here, it has the checkboxes empty. And the specs, it will tell you what are the changes of the requirement, and as this is a new requirement, it will be considered as added, and it is user can enter their name. When the user runs the script, then the system displays a prompt asking for the user's name. So that is how it works. That will be really helpful, as is mentioned in the documentation, because when we do a new, let's say that we want to modify this functionality, so next time that we do that, this will be changed. It wouldn't be added, it will be modified, and the new functionality will be described here. That is the idea. So let's say that we are happy with what the AI has returned to us. So let's say, okay, I want you to apply those changes. So OPSX apply. So implement tasks from OpenSpec change. Open OPSX apply. So in a few time we should see here the Python file called grid.py. It is here. It is checking the boxes. The grid.py file was created. The implementation, add prompt for username input, add greeting. So it looks like the grid.py file is finished. Let's give it a look. Oh well, and as you can see, it's quite simple, and it doesn't even require to run this little script. We will require to use Python in the terminal, or maybe we can modify it to make it to execute it with just like a simple file. So that is something that we can also modify on this file. So it says here that it is finished. So let's verify if it is really working. Okay, ls python 3 grid.py, it should ask my name and it return my name. Okay, we verify now that it is working, and the design file design.md file should be remain the same. It should not change. The proposal, the same story, it should not change, and task should be, now it is checked. Now we verify that it was working. We are happy with that. and then we should archive this change. But I would recommend you to, before doing that, you just synchronize your delta specs, I mean the changes, in order to avoid some problems with archive. I was using this tool before, and there are sometimes some inconsistencies because it's a new project, a relatively new project, but it is changing a lot. And as you can see here, in the documentation they mention, well, not here, it's loading. Let's wait a moment. Okay, here it says, which change do you want to sync specs from this change? That change is Python greeting CLI. That is the one that I want to synchronize. So that way, in this specs folder, it will create a CLI greeting functionality. And as mentioned in the documentation, that the files that are located in the specs folder will behave as the source of truth. So let's say that I create a new functionality and I want to return the name, but this time in capital letters. So when I finish that new feature, when I came here in this source of truth, I will see the latest change, the latest modification, that is the latest state of my work. It will be reflected in that document. Requirements, user, ask for the username, and this is the functionality. When the user enters a name, it should return hello, the name. Okay, that's it. So that's it. It's synchronized with the specs folder. And now, okay, let's see if this, okay, it fails. Okay, what I want to tell you is about the changes is this. They are mentioning that there is a new workflow, that they have rebuilt OpenSpec with a new guided workflow. So for that reason, I told you it worked for me to synchronize the delta specs changes before doing the archive, because when I did first the archive, I had some problems. So once we did the synchronization, we can continue with the archive. So what should happen here is that this change that will work, Python greeting CLI, should be archived and should be put inside this folder. The idea is that the folders or the changes that are outside of this folder, okay, I want to archive the Python greeting CLI change. The idea is that the changes that we are currently working on are outside of archive, and when we finish our changes, these changes go to the inside the archive folder. So yeah, as you can see here, automatically this change, Python greeting CLI, is now inside archive, and it's already it added automatically what is the date. So that helps us to keep a record of our work. So that's fine. And okay, let's say that we are happy with that change. Now in a real use case, we want to let's say modify this functionality, and now we want to rather than return a just the name, maybe we can ask the AI to update my functionality and return that name in capital letters. So let's do that. OpenSpec propose. I will say to the AI, I want you to update my CLI functionality. This time the name of the user must be in capital letters. Okay, that is the new change that I want to propose. So here it will do the same stuff. Based on my intention, it will create a change name, in this case uppercase name greeting, and as it is a active change, it will be inside of the changes folder but outside of archive folder. They are not in the same level. And of course, when we do the proposal, it will create the 4 artifacts: the proposal.md here, the the name of the other is the proposal.md, the design.md, and the tasks.md, and also the specs folders inside. So let's give it a time. Okay, design, proposal, the specs, and as you can see here, when it creates the specs folder, it does not create a folder with the name of the current change, that is uppercase name greeting, but with the name of the change that was previously created, that is CLI greeting. Why? Because it is updating that functionality. For that reason is that it does it create with the same name. So the AI is intelligent enough to detect that we are updating an existing functionality. That is the idea. So once it's that, let's check what is the proposal. The proposal, it is the current greeting display the name as entered. For consistency and formatting, the name should be displayed in uppercase letters. Okay, that is simple. The design, it should be something similar. User wants the name displayed in uppercase. I mean, everything, the remaining stuff should be really the same. The task, in this case there is only one task: to modify grid.py to uppercase the name before printing. Okay, and the specs here, that is something important. That is what I told you before. The OpenSpec is smart enough to detect that we were working in an existing feature, and now it will not be an added requirement, but it will be a modified requirement. So that will help us to keep track of all our changes. Okay, that's perfect. But let's say that we want to modify, we are not happy with this change. Let's say that is something that could happen. And let's say the idea is that you can modify each of these files or artifacts by your own. So that way, if there is something you don't like, you can update it, or you can just get rid of it. the design MD, proposal, or task. But you should take into consideration that you should update the files that are affected by that change. So that could be something tedious to check each artifact. So probably the best way to work it out is just to tell the AI to do the modification for us. So in this case, I will change the greeting, and I rather, so something simple also. Yeah, so rather than using a one exclamation sign, we will use 3, just to speak. Okay, so let's go ahead. I want you to update the files related to my recent OpenSpec change rather than ending the greeting with a single, you must use 3. So that's it. So in this case, it should modify, it could be the spec.md, the design md, the proposal. So in this case, as you can see here, it's modifying the proposal.md from 1 exclamation sign to 3. Here the proposal.md also is specifying the triple exclamation marks. Design md also use triple exclamation marks. The spec.md also triple exclamation marks, and even in task.md. So let's say that we are happy with that. So let's say, I want you to apply those changes. Apply. And just let's wait until that is finished. So let's see that I would recommend you to, even though here is the official page of OpenSpec, I would really recommend you to work with the repository, because as I told you, this tool is, or this framework is working, is being changed, and sometimes you can get confused because there are some inconsistencies here. For example, okay, learn, getting started. Okay, for example, if you go to the getting started section of OpenSpec, they will tell you to do what we did before. Go to your project, OpenSpec init, but here it will say the following: create the OpenSpec directory. Okay, that's correct. It will generate configuration files, and it says it will create an agents.md files with instructions for the AI assistant. For example, that happened before. When you use OpenSpec, it created that agents.md. So if you work with OpenCode, for example, that is a file that you use to give a summarized context of your work, or what are your guidelines for, what are the guidelines for your project. So when that was modified in order to not overlap with that file. So for that reason, I would recommend you to work with the official documentation, the official repository. That is the best. So, okay. it looks like it finished with the implementation. So let's verify if it is true. Python 3 grid.py Python 3 grid.py. Oh, and as you can see here, my name is in capital letters and we have 3 exclamation marks. Perfect. Now that we are happy with that, we can see again that that task is checked now. It was implemented. We are happy with the changes. So we are going to, let's synchronize just in case. And I want you to see this. This is the spec. Oh, and I want to apply the synchronization to my new functionality, uppercase name greeting. I want you to check that the previous spec file, we have this, just return the name and a single exclamation mark. So it is supposed that if this file is the source of truth, it should be updated with our new functionality. Oh, and as you can see here, it was updated right away. Hello Alice in capital letters, 3 exclamation marks. Perfect. So that is what is really interesting about this, because it can identify what is the feature that you are working on. CLI greeting, it was updated, and you can, and this part of your, and this folder specs is your source of truth. That is what is the latest changes that you have. And if we go here, this is the modified. So this helps the OpenSpec to track what are the changes, what was added, what was modified, what was removed, and keep updated our source of truth, in this case the specs folder. Perfect. So once we synchronize that, let's archive our change. Okay, probably it will ask what change. Well, in this case, yeah, it asks for what is the change that they want to archive. Okay, that's okay. And as before, it should move this this folder here, our change, to the archive, because we already finished with that functionality. And that should be all to work with to finish this tutorial. Yeah, and that's it. As you can see here, that change was archived with the name of the change, the date, and the specs were synchronized to the main specs here. That is, the specs that we see here were synchronized with the main specs of that functionality. So that is how you work with this with OpenSpec codes. As I told you, it's a good tool if you are working as a solo developer. It's an MVP, a small project, a proof of concept, because it really allows you to move very fast and to store your changes, to keep track of your changes. And that's it. I hope you like it.